Hi there. What we have here in this video is an electrical circuits problem. So we have an electrical circuit over here with a 9-volt battery and then a bunch of resistors. And what we're going to try and do is we're going to try and find the current through a couple of those resistors. All right? Now, the way we're going to do this problem is we're going to look for ways to simplify our electrical circuit. Okay, and what that means is that we're going to look for combinations of resistors that are in series or parallel so that we can replace them with their equivalent resistance. Okay, and that'll give us something a little bit simpler. And actually, with this circuit, we're going to be able to do it all the way down to a single equivalent resistance for the entire circuit. Okay, so let's get started. Let's see. So if we look for combinations of resistors that are either in series or parallel, the first thing we see is that R2 and R4 are two resistors that are in series. And that means that we can replace them with a single equivalent resistance, which I can write. I'm going to write this as R24, and for resistors in series, the equivalent resistance is just the sum of them. Okay? And so R24, the equivalent resistance for this combination of resistors, is going to be 75 ohms plus 90 ohms, which is 165 ohms. Okay? Now, just to help us as we proceed here, I'm going to redraw the circuit at each stage, okay? Because what that'll do is it'll make it simpler to see what our next simplification is. And also later on in the problem, when we actually get around to looking at these currents, it'll help us sort of drill back down to the individual resistors. So let's see, if I replace R2 and R4 with their equivalent resistance, then my circuit is going to look something like this. I've got R1 here, I've got R3 here, and I've replaced R2 and R4 and with a single resistance, R24, okay, which is 165 ohms. Okay? Now if we look at our new circuit, we can see that in fact this consists of, well, we have here R3 and R24 are two resistors that are connected parallel to each other. Okay, notice they're not geometrically parallel. I mean, I haven't drawn them parallel, but remember that electrically speaking, parallel means they're connected at both ends. Okay, and so the left end of this one is connected to the top of R3, the bottom of R3 is connected to the right end of R24. Okay, and so the equivalent resistance for these two resistors, which I'll call 1 over R, well, I'll call it R234, okay? For resistors that are parallel, 1 over the equivalent resistance is going to be 1 over R3 plus 1 over R24, okay? And that is 1 over 85 ohms plus 1 over 165 ohms. And when I work this out, and then remember I have to take the reciprocal of it also. You know, in other words, when I add these up, that's 1 over R234. So I got to take the reciprocal to get R234. R234 ends up being, let's see, I got the number here somewhere, 56.1 ohms. Okay? And so we've taken R3 and R24 and we've replaced them with a single equivalent resistance, which means that if I put that in, my circuit now looks like this. Okay? Where this is R1 and this is R234. Okay? And then once I've done that, we see that R1 and R234 are in fact two resistors in series. Okay, they're connected at one end with no branching out in between anywhere. That's what we mean by series. And so basically I can replace those with a single resistor, which is going to be the resistance for my entire circuit. So the equivalent resistance for my entire circuit is going to be R1 plus R2, 3, 4. Remember, for resistors in series, we just add them together. Okay? And this works out to 60 ohms plus 56.1 ohms, which is about 116 ohms. Okay? So this is my equivalent resistance for the entire circuit. All right? Now, of course, I'm not really where I want to be yet because I'm trying to calculate currents here. Okay? But this is basically, in actually trying to calculate the currents, this is kind of going to be my starting point here. Okay? So essentially I've got my circuit down to this. Okay, there's my 9-volt battery. And there's my equivalent resistance for the entire circuit. Okay? So once I've got that, I can now I could calculate the current that my battery supplies. Okay, so we're going to use Ohm's law here. In this case, the voltage across this resistor is my battery voltage. So E is equal to I times R equivalent. Okay, so this is 9 volts equals I times 116 ohms. And this tells me then that my total current in this circuit is 0.0775 amperes. Okay, so that's the current supplied by my battery. Okay, and that also means that that's the current running through my R equivalent in this circuit here. Okay, now here's the thing. My R equivalent, which has this much current flowing through it, actually consists of two resistances, R1 and R2, 3, 4, in series. And when you have resistors in series, the current going through the whole thing is equal to the current going through each of them individually. Okay? In other words, the electric current flowing through resistors in series, they've all got to be the same because there's nowhere else for the current to go. Any current that goes through R1 has no place to go except for R2, 3, 4. Okay? And so that means that this current I just calculated over here is in fact the current going through R1, and it's the current going through R2, 3, 4. Okay? And now that I know the current going through R2, 3, 4, I can calculate the voltage across this section. In other words, once you find out a new piece of information about some part of your circuit, then, calculate anything else you can. So I'm going to say delta V 234 equals I 234 R 234. In other words, I'm taking Ohm's law and I'm applying it specifically to this portion of my circuit. Okay? And I234 we just found is 0.0775 amperes. R234 we've been saying is 56.1 ohms. Okay? And that gives us 4.35 volts, which is delta V 234. Okay? So we've calculated everything we can about this portion of my circuit, right? I got delta V, I got R, I got I. Okay? Now let's look and see what this is. Okay? R234, remember, going back to here, consists of two resistances, R3 and R24, that are parallel to each other. Okay? And what we know about parallel resistors is that the voltage across each of them is the same. So this 4.35 volts, in addition to being delta V234, because this consists of two pieces in parallel, this is the voltage across each of those pieces. So it's delta V3 and it's delta V24. Okay? Now, delta V3, notice I want to know the current through R3. I can get that because I now know what the voltage is across it. So I can say delta V3 is equal to I3 R3. Okay. Delta V3 is here, 4.35 volts. R3 is 85 ohms. And so this is going to give me I3 equals 0.0512 amps. Okay. Hopefully I'm almost done because I'm almost out of room here. Okay. So I can also use this to calculate I24. In other words, the current going through this part. Because delta V24, so I can say delta V24 equals I24 R24. This gives me delta V24 is 4.35 volts equals I24 times R24. Let's see, R24 is way up here, 165 ohms. And this tells me that I24 is equal to, let's see, 0.026 amperes. Okay, so that's a 0.026 there. All right. And I'm now out of room on this sheet, but that's okay because, in fact, notice that since the 2,4 part of my circuit actually consists of two resistors in series, that means that this current I24 is in fact I2 and it's equal to I4. So I can say I2 equals 0.026 amperes. Okay? And that's what I was trying to find.